Good morning, everyone. Hope you're all doing very well. Before I get into today's topic, which is about radicals and fractional exponents, I just want to recap all the rules that you should have been going over, that most of you have been. There's still some of you who have not done the work we've assigned, but most of you have, which is very good. Thank you. The first rule, the product rule, is if we've got x to the power of a times x to the power of b, meaning you're multiplying common bases, then what you do is you keep the base and you add the exponent. So x to the a times x to the b equals x to the a plus b. First rule. Second rule is the quotient rule, because you're dividing. That's x to the a divided by x to the b, also written as x to the a over x to the b. So you're dividing common bases, you keep the base, and you subtract the exponent. So it's x to the a minus b. No problem. Third rule, the product rule, if you've got x to the a, that whole thing is being raised to the power of b. Then when you've got a power raised to a power, what you do is you keep the base and you multiply the exponent. So it's x to the a times b. The third one, I call it the expanded power rule. Whoops, I just dropped my pen. The expanded power rule says if we've got x times y in parentheses being raised to the power of a, then what you do is you kind of distribute. Think of it, and I'm saying that in quotes because it's not the distributive property, but think of it that you're distributing that exponent to both the x and the y. So it's x to the a times y to the a. Then, similarly, it also works if you're dividing inside. If you got x over y, that whole expression being raised to the power of a, then you give that exponent to both the numerator and the denominator. So it's x to the a over y to the a. Then we've got the zero power rule, and it says anything raised to the power of 0, anything other than 0, is equal to 1. So you've got this whole big expression in parentheses raised to the power of 0, it equals 1. Then comes the negative exponents rules, which we did yesterday. So if we've got x to the negative a, that's 1 over x to the positive a, and 1 over x to the negative a equals x to the a. So that's recapping all of the rules you should have gone over so far, and now we'll get into our fractional exponent rules. So when you're working with fractional exponents, if you guys remember, we've got a base of x and is raised to the power of a over b, then that fraction means we are going to have a radical, okay? The base goes underneath. It becomes the radicand. It's what's underneath the radical. The denominator of our fraction becomes the index, which is telling us what root we're working with. And then that numerator, that a, it becomes the exponent. It can go either inside or it can go outside. This is the same thing as the bth root of x, the whole thing being raised to the power of a. These last two, that's a little off screen, sorry. These last two are equivalent to each other. So if we are given an expression and it says the fourth root of m and the whole expression is being raised to the third power, and you're told to write it in exponential form. So the radicand, which is the m, becomes the base, the radicand becomes the base, so it's m raised to a power. And we know that since there's a radical, we're going to have a fractional exponent. The index, which is telling us it is the fourth root, becomes the denominator of that fractional exponent. And the fact that it's being raised to the third power tells us our numerator there is going to be 3. So that's m to the power of 3 over 4. So what if we have a problem set up like this? If we have 2x and that whole expression is being raised to the 2/3 power. Well, the fact that it is a fractional exponent tells us we know we're going to have a radical. Okay. The index, the denominator of that is 3, so we know this is going to be the third root. Now, what's happening with this 2x is you'll notice this whole entire expression is being raised to the 2/3 power. So if we used our expanded power rule I spoke about earlier, then both the 2 is being raised to the 2/3 and the x is being raised to the 2/3. So that's why they're both under the third root. But they're also both being squared. So we keep the parentheses and we're squaring that whole expression. So what's going to happen is this stays the third root of, now what's 2 squared is 4, and x squared is just x. So it becomes the third root of 4x. You have to remember to kind of quote unquote distribute. Make sure you square everything that's inside the parentheses there. You're squaring the whole expression 2x. So there's your recap on fractional exponents and radicals. Work on the worksheet, submit your work, keep working hard, wash your hands, and if you have any questions, just give me an email, okay? And I will see you guys later.